Section 5.5 in Algebra 1, direct variation. Direct variation is an equation that is of the form y equals kx, like you see here. Y is the dependent variable, x is the independent variable. That is not a new teaching, of course. That is just to remind you that x is the independent variable in this situation and all the others too. So as to point out that when we ask for an equation that is a direct variation, there should be an x and a y in the final answer. Oftentimes, I'll get someone who, we give them an ordered pair and ask for the equation of the direct variation, and they just plug the x in for x and the y in for y and think they've got an equation. That's nothing, right? If that were a 2-point question, I'd take both points off on a quiz or a test. What we need to do is come up with an equation that has an x and a y in it, and this is true for the whole year. This is true forever. When we ask for an equation, there should be an independent variable and a dependent variable when it's modeling as these do. Okay, so 3 examples that I have here of direct variation. Y equals 3x is of the form y equals kx. And if I were to graph that, if I plugged a 0 in for x, you'd get a 0 out for y. If I plugged a 1 in for x, you'd get 3 out for y. If I plug 2 in, you'd get 6. That'd be off the graph because I made these small. If I plugged in -1, I'd get -3. Okay, so real quick, I should be able to draw that line. Something like this. This is direct variation. This is also in the form y equals kx. The k value would be 1/2. Y equals 1/2 x. Okay, if I plug in 0 for x, I get an output for y of 0. If I plugged in a 1, then I'd get 1/2, so that'd be like right here. It might be better off to just plug in 2 because then you get that whole number. Oh, sorry, wrong. Try again. 1/2 would be here. And then if I plugged in 2, you'd get 1. And then if you plugged in 4, you'd get 2, like half of 4 is 2. If you plugged in -2, you see how these are all forming a line now, right? And again, you can draw that line. And put arrows on it. Something like that. Oftentimes, someone will oversimplify direct variation and say as one goes up, the other goes up. Okay, and this is to be contrasted with inverse variation, which is going to be the next video. But that's not true about direct variation. As one goes up, the other goes up. What's true about direct variation is that they are related in a constant way. Okay, so as you go from 1 to 2 to 3 to 4, the output is going up by the same value as well. Or to say that differently, they're linear. And not only that, I don't know if you noticed in the first 2 examples, but they pass through the origin. That's direct variation. Passing through the origin and having a consistent rate of change, right? This, of course, leads to slope and slope-intercept form, which is coming in chapter 6. Okay, so y equals -2x is also direct variation, even though the k value is negative. That just means this k value is -2. And again, without doing a cheat chart, if I'm just plugging in 0 for x, I get a 0 out for y. If I plug a 1 in for x, I'll get a -2. If I plug 2 in, I'll get -4. And again, here's a line that we can graph like so. This is direct variation. Now, I just mentioned it, so I might as well just go ahead and throw it out there. You may be familiar with y equals mx plus b. This is a topic in chapter 6, so you don't need to know this yet. But if you're familiar with slope-intercept form, basically that's the form that this is in, but they're calling the m k. For whatever reason, they decided to call that k. By the way, this has a name, and it's called the constant of variation. By chapter 6, we'll know it as the slope, okay? But this is of a particular type, direct variation, because not only does it have that k instead of an m, which is just a subtle difference, just a difference in the way they model things, but also this plus b, which is known as the y-intercept, that's always 0. Y equals kx plus 0. We just don't bother writing the plus 0 in here, knowing that that's what it's going to be. And that goes back to the fact that all of these are passing through the origin. Okay? Now, with that, a couple of examples. This says, is each equation a direct variation? If it is, find the constant of variation. I just defined for you what the constant of variation is. That's the k value. So if it's direct variation, we can find k. basically there's just like 3 different ways they can ask you the direct variation question, and here's one. Basically, they're saying, can you make it look like y equals kx? So let's see. The key characteristic of this is the fact that y is by itself. So y is being multiplied by -3 and then added to 2x. So what if we subtracted 2x? Keep the negative on the 3, right? You subtracted 2x, now this is -2x, and then this is still 1. If I divide by -3, you're going to have -2x divided by -3, which would be positive 2/3 x, and then 1 divided by -3 would be like saying -1/3. Now that is not in this form here. That's not in y equals kx form because it does not have a y-intercept of 0. Okay, now again, if you don't know the term y-intercept yet, that's coming in chapter 6, but basically you've got this number here, which y equals kx does not have a number here, which implies 0. So this is no, not direct variation. What about this one? Subtract 2x from both sides. 0 minus 2x is just -2x. Divide by -3, and you'll have -2 divided by -3. Go ahead and simplify the negative divided by negative, and you have 2/3 x. Y equals 2/3 x. Yes, it is direct variation, and the k value is 2/3. This does look like this, and the k value then is the 2/3. The constant variation is 2/3. Next one says write an equation for the direct variation that includes the point -3, 2. All right, now let's take a little moment on this one. Y equals kx. And the x value is -3, the y value is 2. We could plug things in. Again, this is worth no points right now. Okay, if you just do this and stop, that's nothing. We want to find the k value so that we can plug it back in for the equation. They said write an equation. So if I divided both sides by -3, now you've got 2 divided by -3, which is the fraction -2/3. The k value is -2/3. Then you can rewrite the equation that is y equals -2/3 x. This is worth the points. Sometimes I'll put this as an answer blank too. Right? Maybe make that worth 2 points. Let's just do this again. What if the point were 2, 7? Well, then you could go y equals kx, and you could go 7 in for y and 2 in for x, and you could divide both sides by 2, and that would be 7/2, or maybe you go with decimal 3.5. That's what k is equal to, is 3.5. And then you could rewrite the equation with that 3.5 in for k, and it would be y equals 3.5x. Now think about this. Didn't we do the same thing both times? Didn't both times we plugged something in for x and something in for y, then we both divided both sides by whatever that x value was? Think about it in general terms now, just y equals kx. If I wanted to get k by itself, you could divide both sides by x. This would be y over x is equal to k. If I do this, divide by the x. The x's would cancel, and you've got k is equal to y over x. If you read through your textbook, you'll even see that k is equal to y over x. I want everybody to agree right now, please, model direct variation this way, right? This way, and not this way. Okay, it's okay to think of it this way, but this is not how we want you to see direct variation. All right. Now, that being the case, if I go back to this problem, that I really need to do all this work that I showed. If I can remember that all you have to do is divide the y by the x, then you could just take the 2 and divide it by -3, and immediately you'll have the k value, which is -2/3. K is -2/3. And then you can write your equation y equals -2/3 x. That's what we had before. Divide the y by the x, 7/2, or 3.5. Y equals 3.5x is the equation because the k value is 3.5. Okay, a couple more. The weight an object exerts on a scale varies directly with the mass of the object. If a bowling ball has a mass of 6 kilograms, the scale reads 59. Write an equation for the relationship between weight and mass. Weight and mass. Now think about this. Does one depend on the other? I would say that the scale reading depends on the mass of the object. And the way the experiment is described here, if you think of it like an experiment, I would say that the weight depends on the mass. You take something, you put it on a scale, you already know its mass, you put it on a scale, you record its weight. The weight is dependent on the mass. So that being the case, the weight being the dependent variable, the mass being the independent variable, I would say that this is the ordered pair 6, 59. Okay? Mass, weight. And I'm writing that down just to remind myself that, right? It says write an equation for the relationship of weight and mass. Divide the y by the x. You'll have 59 divided by 6. The k value would be 59.6. Now, if that reduced to something nice, I'd give you the number, but actually 59.6 does not. So the equation that we're looking for then is simply y equals 59.6x. Just like that. Okay, one more, and then I've got one back on the Starboard software to finish up. It says for the data in the table, in each table, use the ratio of y over x. Okay, so we're trying to remember that you divide the y by the x, and you can get the k value to tell whether y varies directly with x. If it does, write an equation for the direct variation. Okay, now I wish they hadn't done this here, but they actually did put this column in already. So that being the case, what they've done is they've divided the y by the x. 1 divided by -2, they got this number. -1 divided by 2, they got this number. -2 divided by 4, they got the same number. Do you notice that these are all the same? This is the word constant. It's a constant of variation because it came out to the same number each time. So the answer to this is it direct variation? Yes. What's the constant of variation? K equals -0.5. That's the constant. If you divide the y by the x and you get the same number each time, it's constant. And then write the equation, y equals -0.5x, or -1/2 x if you're going to go fraction. They went decimal here, so I kept it. Now they do the same thing here. Divide the y by the x. 2 divided by -1, that's -2. 2 divided by 1, oh, that's 2. And then here you get -2 again. These are not constant, right? So this is not direct variation. We would say no. All right, and then lastly, this is kind of the quintessential variation problem. We'll do the same thing with inverse variation. It says y varies directly with x, and then when x equals 9, y equals 4, they want us to find y when x equals 36. Here's the naked truth. You could set up a proportion and solve this. Yes, you could. However, I'm not going to ask the question with in this way on the quiz or the test, the way you see it here, right? Oh, just this information and you just have to answer one thing. No, I'm going to ask it step by step. Find k, find the equation, and then find the missing value y. And the reason that I do this is because the next video is going to be on inverse variation, and then you can't set up a proportion. So I want to train you now to do it right on direct variation, and then it'll transfer very well to inverse variation. So let's find the k the way we were always finding k. Divide the y by the x. 4 divided by 9. The k value is 4/9. Didn't take any work to do that. And then the equation would be, I did not mean to put equals there. I beg your pardon. I don't want to be confusing there. The equation doesn't equal something that has an equal sign in it. I should have put a colon. Y equals 4/9 x. If I did a quiz problem like this, I'd probably do this, and these would each be worth 1 point. Okay? Now that you have this equation, now you can answer the question. What is y when x equals 36? By the way, when x equals 4, y equals 9, that is the ordered pair 9, 4, right? And if they said it the other way around, when y equals 4, when x equals when y equals 4, x equals 9, that's the ordered pair 9, 4. You got to link these together. And then again, what we did was we divided the y by the x, 4/9. Okay, so then to answer the final question, which is really what we're trying to get to, you're going to plug that 36 in for x, this 36 in for x. And that would be 16, wouldn't it? 4/9 of 36. 36 divided by 9 is 4 times 4 is 16. Okay, so just to end this now, on the coordinate grid, you've got the point 9,4. I'm not showing a scale here, but just to give you an idea, you got the point 9,4. You have now the point 3616, which would be like way out here, right? But also you'd have the point 00. These all lie on the same line. I don't just know 2 points, I know 3. One of them was the point they gave me. One of them was the one that I found when I plugged 36 in for x to get y. So 36 comma 16 is a point. But don't also forget that always 00 is a point. So there's 3 points that we know. Thanks for watching.